This video explains how to configure Ethernet IP communication between an Allen Bradley PLC and Mech-Mind vision system so the PLC can coordinate vision-guided robot picking operations. Our focus is on the communication setup and communication test. Ethernet IP communication between an AB PLC and the Mech-Mind vision system can be implemented in two ways. Choose one that best fits your project requirements. This video demonstrates the software-based configuration. The main workflow includes: prepare hardware and software, configure communication on the Vision IPC, configure communication with the controller, configure communication with the Vision system, import example programs, download the PLC project to the controller, and confirm communication. The detailed procedures follow. First, preparations. Confirm that all required hardware and software are available. The versions and models shown in this video have been thoroughly tested and are recommended for use. When preparing software, pay attention to the installation locations. Then verify the hardware connections. Ensure the Vision IPC, Engineering PC, and controller are on the same subnet and connected to the same EtherNet switch. This ensures proper data exchange over the network. Also, on the Vision IPC locate the required communication files under the Mech-Vision and Mech-Viz installation folder, including the EDS file and the PLC example program files. In this case of software-based communication, we use the EDS file as shown. In addition, 3 example program files are included. Copy these files from the Vision IPC to the engineering PC used for AB PLC programming for later import. After preparations, start the communication service on the IPC. Open Mech-Vision and, depending on your scenario, open an existing solution or create a new one. Click Robot Communication Configuration on the toolbar. According to your project, select the robot in use. Next, set interface service type to standard interface, and protocol to Ethernet IP software. Also, select the network adapter and IP address used by the IPC for communication. Remember to record the IP because the module IP to be added in Studio 5000 must exactly match this address. It's recommended to auto-enable interface service when opening the solution. Apply the configuration. Make sure the robot communication configuration switch on the toolbar is active. After finishing the IPC configuration, use Studio 5000 to create and configure the PLC project to establish Ethernet IP communication with the controller. Open Studio 5000 on the engineering PC. Create a new project. Select Logics, choose the CPU family and exact model that match the AB PLC. Enter the project name and choose a location to save the project. Next, set revision and configure expansion I/O according to your module layout. Click Finish to create the project. Subsequently, assign a fixed IP to the controller using Ethernet IP address commissioning tool. Launch the tool and select the Ethernet adapter connected to the controller. Choose the discovered entry that corresponds to the controller and add it to configuration. Then, enter the host name and the desired IP for the controller. Confirm the entry appears under Assigned Requests. Set the controller's IP mode to static, which will cause it to adopt the configured address rather than using DHCP. The commissioning tool will push the new settings to the device. After applying the change, you should see a message confirming successful mode switch. Now that the controller holds the configured IP, close the commissioning tool. Next, allow the engineering PC to discover the controller and establish an Ethernet IP connection. Search for RS-Links Classic. Go to Communications, Configure Drivers. Add an Ethernet IP driver instance so the PC can browse Ethernet IP devices. When prompted, select the Ethernet adapter connected to the PLC. This binds the driver to the correct network interface for communication. After the driver instance shows as running, close the window. In Studio 5000, navigate to I/O configuration, EtherNet, select your CPU module, and launch the Who Active tool to discover controllers. Expand the driver node if necessary, select the CPU module to be connected, and click Set Project Path to assign the controller as the project's target. Once the project path changes, close the window. The next step is to establish communication with the Vision system by binding an Ethernet IP module to the Vision system's IP. To begin with, register the Vision system's EDS. Under Tools, open EDS Hardware Installation Tool. In the Device Wizard, select Register a Device Description Files, then register a single device description file, and point to the EDS file copied from the IPC beforehand. Click Next through the wizard to complete the registration. It's now possible to add and configure an Ethernet IP module. In the Controller Organizer panel, right-click Ethernet and choose New Module. Select the module type that matches the device registered via EDS so Studio loads the correct module definition. For this software configuration scenario, search for Mech-Mind standard interface and create a module of this type. Enter the name consistent with the example name. Furthermore, set the module's IP address to the Vision system's IP so the controller can exchange data with the Vision system. In this case, it must exactly match the network adapter IP set earlier in Mech-Vision. In the module definition window, set the size type for the I/O data to int and confirm the setting. After the module appears in the Ethernet device tree, close the configuration window. Proceed to import Mech-Mind's example programs to the project. First, import the add-on instructions so the project recognizes the custom instruction blocks used by the Mech-Mind Ethernet IP interface. Navigate to File, Import Component, and choose Add-on Instruction. Select the sample AOI file copied from the IPC. Click OK to run the import. Upon completion, verify the AOI import. Confirm the imported AOIs appear under Assets, Add-on Instructions. Then, import the first routine. Use File, Import Component, Routine, and select the Camera Signals Move file. Next, repeat the routine import and choose the camera test file. The custom instructions and routines required for Ethernet IP communication with the Vision IPC are now imported. Now insert subroutine calls for the Mech-Mind logic into main routine and download the updated project. Find Tasks, and double-click main routine to open it. On rung 0, insert a program control, JSR instruction and configure it to call camera signals move. Double-click the parameter drop-down to clear its mapping. Studio 5000 will hide empty parameter slots, which is a quick way to tidy the rung, but don't clear parameters that the routine requires. Copy and paste the rung containing the first JSR to create rung 1, and edit the pasted JSR target to camera test. Then, use download to transfer the offline project to the target controller. When the download finishes, change controller mode back to remote run. Verify the controller mode displays REM run. After switching modes, validate the downloaded logic is running. Double-click camera signals move to open it. Monitor the tag from camera.heartbeat used on rung 21, which should update periodically. This indicates an active heartbeat from the Vision IPC and successful data flow into the PLC. On the IPC, open Mech-Vision's log, console tab and check for messages indicating a successful Ethernet IP connection. This completes the Ethernet IP communication setup between AB PLC and Mech-Mind Vision system. The next part shows how to use the imported example program to trigger a Mech-Vision project to obtain Vision result. thus validating successful data exchange. This scenario employs the eye-to-hand camera setup with a single Mech-Vision project. Here's the main configuration flow. First, enable communication to establish the connection between the PLC and the vision system. Next, set the Mech-Vision interface parameters. Only 3 input parameters need to be configured: the vision project ID, the number of poses to be returned, and the robot pose type. The remaining parameters are set by the previously imported AOIs and do not require modification. Then enable Start Vis to launch the vision project. Finally, enable Get Vis Data to obtain the vision result. For detailed definitions of the parameters, consult the standard interface commands. Let's move on to the specifics. Before getting started, auto-load the solution in Mech-Vision. Then back to Studio 5000 on the engineering PC, under Tasks, open Camera Test. First, verify that communication is enabled. This confirms the PLC trigger signal can reach the vision system. Afterwards, configure the interface parameters on rung 3. To begin with, specify the Mech-Vision project to run. In this case, there is only one project with ID 1, so keep the default. Next, set the expected number of poses to be returned by the Mech-Vision project. For this scenario, we require all the poses, so set the value to 0. After that, set the robot pose type, which defines the type of robot pose that would be sent to the Mech-Vision project. Because the camera here is mounted in eye-to-hand mode and there is no need to capture images beforehand, set the value to 0 to indicate no robot pose provided. The other parameters can remain at their defaults. Subsequently, trigger the Mech-Vision project to run. To this end, enable Start Vis by setting camera user step number to 5. Then set camera user Start Vis to 1 to initiate the start command. After issuing the command, monitor the status code in the watch panel to verify the trigger succeeded. Add the From Camera status code tag and confirm it returns 1102, indicating the project started normally. If any other error code appears, please refer to our documentation for troubleshooting guidance. Once the start is confirmed, set camera user Start Vis back to 0. Now that the project runs successfully, we need to call the next command so the PLC can obtain the vision result. On rung 4, enable Get Vis Data by setting camera user step number to 10. Note that the project number here should match the one configured for Start Vis. Modify camera user Get Vis Data to 1 to request the vision result produced by the Mech-Vision project. Check From Camera status code again. A value of 1100 indicates the Get Vis Data command executed successfully. Upon confirmation, reset camera user Get Vis Data to 0. Now add target pose to the watch panel. Expand the tag to view the returned pose data. These values represent the vision project output, namely the robot picking poses. At this point, testing of the Mech-Mind example program is complete. To automate the process, please refer to the example MMS1 Vis Basic. More detailed instructions on configuring EtherNet IP communication between AB PLC and Mech-Mind Vision System can be found in our documentation.